In the last video, we discussed the trigonometric ratios of any angle. In this video, we will discuss the trigonometric ratios of compound angles. So compound angles as a plus b, a minus b, a plus b plus c, and so on. An angle which is sum of two or more angles is known as a compound angle. So today we will discuss how to get the formulae cos a plus b, sin a plus b, tan a plus b, cos a minus b, sin a minus b, and tan a minus b. So let's get started without wasting much time. Let's derive the formula cos a plus b. Cos a plus b is cos a cos b minus sin a times sin b. Now let's see how to get it. So here I have drawn a unit circle, and by unit circle I mean a circle with radius 1 unit. And in that unit circle, I have drawn a triangle POQ, where angle POQ is a triangle ROQ, where angle ROQ in clockwise direction is minus B, and a triangle SOT, where angle SOT is A plus B. Here, point P is same as the x coordinate, which is OQ, and comma y coordinate, which is PQ. But if we look in the triangle POQ, we'll find out that OQ is same as cos A. Why? Because cos A is adjacent side, which is OQ in triangle POQ, divided by the hypotenuse, and hypotenuse is the radius of the circle here, which is 1. So cos A is same as OQ, and similarly we can easily prove that sin A is same as PQ. That means the coordinates of point P can be given by cos A, comma sin A. In the similar manner, we can prove that the coordinates of point R are cos of minus B, comma sine of minus B. And as we have learned in the previous video that cos of minus B is same as cos B, and sine of minus B is minus sine B. So point R can be given as cos B, comma minus sine B. In same way, we can prove that point S is cos A plus B, comma sine A plus B. And point T can be given as 1, 0, because it's a point on x-axis, and we know that the radius of the circle is 1 unit. So this point will be 1, 0. Now, if we look at triangle POR and triangle SOT, we can easily prove that triangle POR and triangle SOT are congruent. The reason being PO is same as SO, radius of the circle. OR is same as OT, again radius of circle. And angle POR, which is A plus B. Here I'm talking about the magnitude of angle B. We are not talking about the sine, because when you are in a triangle, you measure the angle positive and not negative. So angle POR is A plus B. Similarly, angle SOT is also A plus B. So in magnitude, angle POR is same as angle SOT. And now we have proved that these two triangles are congruent. And in two congruent triangles, their corresponding parts are equal. So we can say that length PR should be equal to length ST. As PR is equal to ST, we can also say PR square is equal to ST square. We know that point P is cos A comma sine A, point R is cos B comma minus sine B, point S is cos A plus B comma sine A plus B, and point T is 1 comma 0. We can apply the distance formula, which is given as x2 minus x1 whole square plus y2 minus y1 whole square root to find the distance PR and distance ST. And as we earlier discussed, if PR is equal to ST, that means PR square should be equal to ST square. So we can get rid of the square root. And if we apply this formula, we will get PR, which will be cos B minus cos A whole square plus minus sine B minus sine A whole square equals 1 minus, so st square, 1 minus cos A plus B whole square plus 0 minus, so we can simply write minus sine A plus B square. So if we simplify the left hand side further, we'll get cos square B plus cos square A minus 2 cos A cos B. Similarly, minus sine B minus sine A whole square, we will get sine square B plus sine square A plus 2 sine A sine B. And on the right hand side, we'll get 1 plus cos square A plus B minus 2 cos A plus B plus sine square A plus B. Now, on the left-hand side, we have cos square A plus sine square A. We know that is 1. And cos square B plus sine square B is also 1. And on the right-hand side, cos square A plus B plus sine square A plus B is also 1. This is by using sine square theta plus cos square theta is 1. That means we have the left-hand side as 2 minus 2 cos A cos B plus 2 sine A sine B. And on the right hand side, you have 2 minus 2 cos A plus B. Further, we can cancel out 2 on both sides. That is, by subtracting 2 on both sides, you can cancel out that 2. So we are left with 2 minus 2 cos A cos B plus 2 sine A sine B. And on the right hand side, we are left with minus 2 cos A plus B. And we are trying to find cos A plus B. So we will divide both sides by minus 2. So if you divide both sides by minus 2, we will get cos A times cos B minus sine A times sine B equals cos A plus B. And this gives you the formula cos A plus B is equal to cos A cos B minus sine A sine B. To get the formula of cos A minus B, we can simply replace B with minus B in the above formula that we obtained. So replacing B with minus B, the above formula will change to cos A times cos of minus B minus sine A times sine of minus B. We know that cos of minus theta is cos theta. So the first term, which is cos A times cos of minus B, will be same as cos A times cos B. But we know that sine of minus theta is minus sine theta. So therefore, the second term will change to plus sine A times sine B. And that gives you the formula for cos A minus B. Now let's go ahead and prove the formula sine A plus B equals sine A cos B plus cos A sine B. In order to do that, we will use the formula that sine theta is same as cos 90 minus theta. So we can write sine A plus B equals cos 90 pi over 2 minus theta here is A plus B, which can be manipulated as cos pi over 2 minus A minus B. And if I consider pi over 2 minus A as one term and B as one term, so we have something like cos A minus B. And we have already learned this formula that it will be equal to cos pi over 2 minus A times cos B plus sine pi over 2 minus A times sine B. And using cos 90 minus theta as sine theta, we'll get sine A cos B. And sine 90 minus A will be equal to cos A. So cos A sine B. And that gives you the formula of sine A plus B is sine A cos B plus cos A sine B. And to get the formula of sine A minus B, we'll simply replace B with minus B. So replacing B with minus B, we'll get sine A minus B equals sine A cos of minus B. And we know that cos of minus B is same as cos B. So we'll just keep it as cos B. And replacing B in the second term here with minus B, we'll get sine of minus B. And sine of minus B is minus sine B. Therefore, this plus sign will change to minus. So we'll have minus cos A sine B. So that gives you the formula for sine A minus B is equal to sine A cos B minus cos A sine B. Now let's go ahead and prove tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Starting with tan A plus B, we know that tan theta can be written as sine theta over cos theta. So we can write this as sine A plus B over cos A plus B. And we have already proved the formula for sine A plus B, which is sine A cos B plus cos A sine B over the formula for cos A plus B is cos A cos B minus sine A sine B. And in order to get all the terms in terms of tan, we can divide the numerator and denominator with cos A times cos B. So dividing the numerator and denominator with cos A cos B. So dividing the first term, so sine A cos B divided by cos A cos B plus cos A sine B divided by cos A cos B over cos A cos B divided by cos A cos B minus sine A sine B divided by cos A cos B. So here we can cancel out cos B, here we can cancel out cos A, here we can cancel out cos A and cos B both. So we are left with sine A over cos A, which is tan A, plus sine B over cos B, which is tan B, divided by 1 minus sine A over cos A is tan A times sine B over cos B, which is tan B. And that gives you the formula for tan A plus B. And similar way, we can prove tan A minus B. So to get tan A minus B, simply replace B with minus B in this formula. So let's do that. So now we know that tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. And if you replace B with minus B, the right hand side will change to tan A plus tan of minus B over 1 minus tan A times tan of minus B. And in the previous video, we have learned that tan of minus theta is minus tan theta. So therefore, we can replace tan of minus B with minus tan B. So the formula will change to tan A minus tan B over 1 minus tan A times minus tan B. So minus tan B times minus tan A is basically plus tan A times tan B. This gives you the formula for tan A minus B is tan A minus tan B over 1 plus tan A tan B. So we discussed how to obtain the formula of cos A plus B, sin A plus B, tan A plus B, cos A minus B, sin A minus B, and tan A minus B. There are two more important identities that you should remember, and they can be easily obtained by using the above formulae. And these are sine A plus B times sine A minus B. So if you multiply sine A plus B with sine A minus B, you will get sine square A minus sine square B, which can also be written in terms of cos, which is cos square B minus cos square A. And in a similar manner, if you multiply cos A plus B with cos A minus B, you will get cos square A minus sine square B. Now let's go ahead and look at some examples on how to use some of these formulae. The question is, if A plus B equals 45 degrees, show that 1 plus tan A times 1 plus tan B equals 2. So here, as you are given with A plus B, and in the required equation, you have A and B. So it points out to tan A plus B formula. So we will try to use tan A plus B formula and try to manipulate it to get the required result. We know that tan A plus B is tan A plus tan B over 1 minus tan A tan B. And if we replace the value of A plus B with 45 degrees, the left-hand side will change to tan 45 degrees. The right-hand side will remain the same, tan A plus tan B over 1 minus tan A tan B. And we know that tan 45 degrees is equal to 1. So the left-hand side is 1 equals tan A plus tan B over 1 minus tan A tan B. And we can multiply the denominator on the right-hand side on left-hand side. So it will be 1 minus tan A tan B equals tan A plus tan B. Now, if we take all tan terms on one side, we'll get 1 equals tan A plus tan B plus tan A tan B. So we got 1 equals tan A plus tan B plus tan A times tan B. The required result, the right-hand side is equal to 2, which can be written as 1 plus 1. And it can be written as 1 plus, and replacing this 1 with tan A plus tan B plus tan A tan B, as we got the value of tan A plus tan B plus tan A tan B equals 1 in the previous step. And now if you factorize this, we'll get 1 plus tan A plus, by taking tan B common from the last two terms, you'll get 1 plus tan A. So you have two factors, 1 plus tan A times 1 plus tan B. And that is equal to the left-hand side of what we wanted to prove. let's look at another example. Here we want to prove that sine b minus c over cos b cos c plus sine c minus a over cos c cos a plus sine a minus b over cos a cos b equals 0. It's quite clear from the question that the numerators of all the terms is in terms of sine a minus b form. So we will try to use sine a minus b formula and then try to manipulate the left hand side and see how it unfolds. We know that sine a minus b is equal to sine a cos b minus cos a sine b. Let's break down the left hand side into three different terms. So starting with the first term on the left hand side is sine b minus c over cos b cos c. If we apply the formula sine a minus b in the numerator, we will get sine b cos c minus cos b sine c whole divided by cos b cos c. Now, this is in the form of b minus a over c, which can be written as b over c minus a over c by using fraction rules. That means we can split the terms here. So if we split terms, we'll get sine b cos c divided by cos b cos c minus cos b sine c over cos b cos c. In the first term, we can cancel out cos c. In the second term, we can cancel out cos b. So we have sine b over cos b, which can be written as tan b, minus sine c over cos c, which can be written as tan c. So the first term on the left hand side, which was sine b minus c over cos b cos c, is same as tan b minus tan c. In a similar manner, we can prove that the second term, which is sine c minus a over cos c times cos a, is same as tan c minus tan a. And the last term, which is sine a minus b over cos a cos b, is same as tan a minus tan b. If we add all these terms, we see that we have tan c and minus tan c, they will cancel out. We have tan a and minus tan a, they will cancel out, and tan b and minus tan b will cancel out. So you will get the sum equals 0. And that is what we wanted to prove. This question, we want to prove that cot pi over 4 minus x times cot pi over 4 plus x equals 1. Starting with the left hand side, cot pi over 4 minus x is same as cos pi over 4 minus x divided by sine pi over 4 minus x. And similarly, cot pi over 4 plus x is also cos pi over 4 plus x divided by sine pi over 4 plus x. Now here, the numerator is in the form of cos a plus b times cos a minus b. And the denominator is in the form of sine a plus b times sine a minus b. And we have already discussed two identities for those two, right? We have already discussed these two identities, that sine a plus b times sine a minus b can be written as sine square a minus sine square b, or cos square b minus cos square a. And cos a plus b times cos a minus b can be written as cos square a minus sine square b. So using these, the numerator can be written as cos square a, here a is pi over 4, so cos square pi over 4 minus sine square b, so b is x, so sine square x, divided by, similarly in the denominator we have sine square a, so sine square 45, minus sine square b, so sine square x. We know that cos 45 is 1 over square root 2. So cos square 45 will be 1 over 2 minus sine square x. And similarly, We know that at 45, cos and sine have the same value. Sine square 45 will also be 1 over 2 minus sine square x. And here the numerator and denominator are same, so we can cancel them out and we'll get equals 1. And that is your right hand side. So in this video, we discussed the trigonometric ratios of compound angles and how to apply these formulae. And in the next video, we will discuss how to convert sum and difference formulae into product formulae and vice versa. Thank you for joining me for this one, and I'll see you in the next one.